All right, hi guys. Give me 1 second. I am just gonna get this pulled up. All right. All right, so we are gonna start with this guy. Okay. So first thing I want to think about is I want to prove these triangles to be equal. So we're gonna focus on that first. You'll see one in a second, but immediately when I see I'm trying to prove that these are perpendicular, that means I want to use equal adjacent angles and plot right angles. So let's go ahead, draw a little T-chart. I'm gonna write my givens. Angle EIN is equal to EMN. And AM is equal to AI. EIN is equal to EMN. Great, so immediately I can see that equals angles give me equal sides. So I can say that MN is equal to NI by equal angles and by equal sides, and that's by line 1. And we'll write our given in. And then immediately I can IDAN, and by CPCTE, I have, or sorry, not CPCTE, by ID. Therefore, I have triangle AMN equal to triangle AIN by SSS lines 2, 3, and 4. Now you might say, okay, why'd you do that? Well, that gives us this triangle here equal to this triangle here. Now, if we look at our second proof, we're trying to get that these are perpendicular. This is perpendicular to that. The only way you get that is by using equal adjacent angles. The problem is you need equal angles to start with. So I want the stars equal to each other. Now, if you notice, I'm never going to have enough information to prove these two triangles to be equal. So I can't CPCTE these just yet. So what I need to do, and the reason I had you prove this first, is because by doing that, now that I've proven this triangle equal to this triangle, I can go on ahead and CPCTE those angles there. So I can say that angle MNE is equal to INE by CPCTE line 5. And then I can ID EN, and therefore triangle MNE is equal to triangle INE by SAS line 7, 6, and 3. And now I can go on ahead and say angle MEN is equal to IEN CPCTE line 8. And again, I'm doing that because once I get these angles equal, well, now I can use this guy to say that they're right. So I can say that MEN is equal to a right angle and IEN is equal to a right angle by equal adjacent angles imply right angles. That's by line 9. And then therefore, because they're equal or because they're right, AE has to be perpendicular to MI by the definition of perpendicular. Because if the angles are right, and they're perpendicular. So that's how you would do that proof. Again, a tricky one, but I put it on here because I really wanted you to have one to kind of think about. This guy's a little bit easier, so I want to show that CFA is equal to DEB. And you've actually already seen a proof like this before. So I'm going to say that CE, and I think we did this one in class, is equal to this. And I can also say GE is equal to GF. Now, as I write those, and I'm actually going to write the straight line one too, because I have an inkling I'm going to use vertical lines, which means I need that one. Now, because these angles are on the outside of the triangle, that gives me an inclination that I'm probably going to want to get those two. Because if I get those two equal, then I can say that these two are equal by steps of equal angles are equal. Two angles, two angle pairs on a straight line. If the green are equal to each other, then the brown gets to be equal to each other. The way we get the green equal to each other is by CPCTE. So to do that, I need to prove the triangle's equal. What I would need to do now is I've got this side of the triangle. So I need to get this side of the triangle, and I'm going to do equal minus equal. So I'm going to do CE minus, you might say, why are you doing that? Because I have the full side, and I just want this one. So I'm going to do CE minus CG is equal to FD minus GD, and then I get CG. This should say GE right here. I get CG is equal to, I did the same thing over here. This should say GF. CG is equal to GD. This is by equal minus equal, lines 1 and 2, and this is by remainders, line 4. Great. And now I've got two sides of my triangle. These are equal because they're vertical and they're straight lines. So angle CGF is equal to angle DGE, vertical angles, line 3. And so therefore triangle CGF is equal to triangle DGE, SAS, line 6, 5, and 2. Again, that allows me to CPCTE, CFG, and DEG. And you're saying, okay, why are you doing that? Because when I get those equal, well then the angles on the opposite sides of those straight lines are also equal. So therefore, CFA is equal to angle DEB, subs of equal angles are equal line 8. That's it. Great. Okay, then we hop over to this one. So this one's got a few. So we've got PQ bisects WX. I've got P is the midpoint of ZY. I've got angle KZW is equal to MYX. And I've got ZW is equal to YX. A lot going on there. Great. So let's go to mark that. So we've got this, we've got these equal. I can already see I'm going to use the steps of equal angles are equal there. Mark the other side. And that's all I can mark right now. So I can go ahead and say some stuff if I want. I can go on ahead and use this one. So it tells me P is the midpoint of ZY. So I can go on ahead and say ZP is equal to PY. And I'm going to write it before I mark it. That's an issue a lot of you have. You like to mark it and then you forget to write it. Make sure you write it down before you mark it. Great. It also tells me PQ bisects WX. So WQ is equal to QX. Now, like I said before, I'm going to go on ahead and say that these angles are equal because we have steps of equal angles are equal. So WZP is equal to XYP And that's by steps of equal angles are equal. Great. And look at that. Now let's kind of take a step back because I've used a lot of stuff that I know, but I really haven't looked at my proof. So here's my proof. I'm trying to show that WQP is equal to XQP. Now, if you notice, we only really have one thing about that triangle, and it's this side right here. But look at the stuff I already have on this triangle. I have enough to say that those triangles are equal. You might say, okay, Miss Verse, why is that helpful? Because if I get these two triangles equal to each other, again, when you prove triangles equal, that opens up the world of CPCTE. And if you see, once I do that, I can CPCTE those sides, and the triangles are almost equal, and then we can say that the angles we want are equal too. So I'm going to go on ahead and say that triangle WZP is equal to XYP SAS lines 7, 5, and I think it was 4. Yep, 4. And then I'm going to CPCT that side. So I have PW is equal to PX. Line 8. Great. Then what I'm going to do is I'm going to say 2, 3, 4. 1, 2, 3, 4. I'm going to say that PQ is equal to PQ ID, and therefore triangle PQW is equal to PQX SSS lines 9, 10, and 6, and therefore exactly what we want. WQP is equal to angle XQP by CPCTE. And that's it. All right, that is it for the proofs. I know those were tough ones, but I'll be honest, if you study these and understand stuff like this, especially stuff like this, especially stuff like this, especially stuff like this, then you'll be fine on the test tomorrow. Other things you might want to study, stuff like this. And again, stuff like that. There are things on your test tomorrow that if you don't see this, you're going to not know how to do almost the whole proof. So please make sure you study how to do that. Okay. I'm not going to go through the constructions. I will post those later. I'm going to go through some of the quants. So it says in the figure above, DB is perpendicular to BC. What is the value of X? Well, over here, I see I've got a full line. So I'm going to go ahead and solve for that first. So I get 18t is equal to 180. So t is going to be 10. Then I'm going to hop over here, and I see that 6t minus 3 plus x is going to equal 90 because it's right angle. Well, then I can take the t that I got here and plug it in right there. So I'll get 6 times 10 minus 3 plus x equals 90. I'm going to go on ahead and move this down here so I can have more space. 60 minus 3 plus x equals 90. 57 plus x equals 90. Therefore, x is equal to 33 degrees. And there it is. Great. So now in this one, these are tricky because I'll see these vertical angles right here. Y plus 10 equals 3x minus 20, but there's two variables there. However, there's another equation I can write. 5x plus 40 plus 3x minus 20 equals 180. So 8x plus 20 equals 180. 8x equals 160. So x will equal 20. Now the question didn't ask what x was, it asked what y is. So now I do the same thing. I take x, put it back in up there, and I get y plus 10 is equal to 3 times 20 minus 20. Y plus 10 equals 60 minus 20. Y plus 10 equals 40, which means y is 30. There she is. Great. All right, again, we're gonna skip a few of these pages. Skip, 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 skip. I will come back to these. Actually, yeah, I'll come back to these. Okay. These ones are tricky. So it tells you that AB is equal to AC, and I want you to find ACD. That's this angle right there. Now, if we notice, we've got equal sides, equal angles. Well, since this is 44, then what's left for both of these is 180 minus 44, which is going to be 136. Now, if we split that into two, we get 68, which means both of these have to be 68. Now, that's not what we want. We want this one. But if you notice, they're supplementary. So I do 180 minus 68, and I get 112, which tells me that ACD is 112. Great. Also here, it tells me AB is equal to AC. Angle B is X, which means this is also X. Now it wants me to find BAC, but I know nothing about them. So I'm going to go ahead and try to find X. Now if you notice, these are supplementary. So X plus 3X plus 30 equals 180. I get 4X equals 150. So X is 37.5. This is equal to 37.5. This is equal to 37.5, which means this is 180 minus 37.5 minus 37.5, which is the same thing as 180 minus 75, which is 105. So 105 degrees. Again, we got this because the sides were equal. Because the sides are equal, these angles are equal. And because those are equal, these are now supplementary. So they equal 180. I solve for X. I plug it back in. I know a triangle equals 180. So this is 180 minus both of those angles. Great. So BAC is 105. Now, I also know that DE, or on this one, I know DE is perpendicular to BC. So these are both right. So this is 90, which means this has to be 40. Now, we want to find DBE. DBE is way up here. Now, this one's kind of tricky. This guy right here has to be 180 minus 70 minus 50, which is 110 minus 50, which is 60 degrees. This is 60 degrees. So, now I can easily find DBE. It's 30. Sometimes you might have to have three angles that add to 180. All three of them add to 180. However many angles you have in that straight line that's how many you have to equal 180. Have to add up to equal 180. So DBE is 30. Great. All right, now name the following exterior angles using the diagram on the right. So exterior angle OSQ. Now here's what you have to do. You have to start at O, go to S, and then you look at the other side that we don't have. So you have this part. So that means we're looking at this. You want to go to this and follow the direction that it's going in. So then the angle is going to be there. OSQ would be here. Again, you do the first direction it tells you to go, O to S, and then look at the other side and follow that direction it wants you to go. So for this one, the interior opposite, there's two of them. We are going to assume for this exercise that we're talking about this triangle. Sorry, I know it's a little bit confusing, but the interior opposite is going to be SOB or SBO. So this one, and also this one. So SOB, and then interior adjacent would be BSO. I would have also taken this angle here and this angle here. Sorry, it's confusing. Actually, Nope, we're just gonna stick with it. So I would have taken a few answers on there. So OBP, so we would go to O up to B, and then we're gonna follow. Actually, okay, we're done.